class. Any questions before we come to today's class?
Can you show an example of the
One more question?
of the trend that you
Expansion of trying to adjust. We don't have time. Still, we don't have time to show the example in class. There's an example on the textbook, and I can tell you. So on page 92 to 93, that's a very simple example to show you how to begin with the trying to adjust expansion smoothing method. 92 to 93. If you still don't get the idea, you can come to my office after today's class or send me an email. I expect many students would have questions about this one, trying to adjust expense smoothing. So don't be shy to send me email or come to my office, especially come to my office, because you should ask me. This is the pretty tricky parts for the homework, right? Okay. So let's first read the example on 92 to 93, and then to see whether you can get some idea. Any other questions? I hope you will definitely spend some time to do the homework in this weekend, and probably you will find some questions pretty easy, but maybe some other questions not so easy. And let me know. I would expect some students will come to my office, especially next week, because so far, well, there's most really students come to my office, which is great for me, right? Okay. So continue our study on chapter 3. We'll finish chapter 3 today, and I'll probably forget to post the chapter 5's notes on Blackboard, but we'll definitely post after today's class. Okay, so we have discussed about seasonality on Wednesday's class, and we have shown that two basic models are widely used to capture seasonality. One is the additive model, and the second one is multiplicative model. Right? We have discussed why sometimes you have to use multiplicative model, because the wave is larger and larger, the fluctuation is larger and larger, then the stable additive model can't handle this situation very well. If that's a situation, you should consider use the multiplicative model. If you decide to use multiplicative model, then we can calculate or estimate the seasonal relatives. That should be an example in the homework question. That's how to use the seasonal relatives to calculate the forecast for the products with seasonality. For cycle, we have discussed, if somebody still remember, what's the difference between cycle and seasonality? What's the difference between cycle and seasonality? Are they the same thing?
One's over a longer period of time.
That's right, as Jack said. Common sense. Not really true, because you talk about cycle, you can be a cycle like one day we have 3 cycles. It's also true. But usually when we talk about cycle, it means longer period than 1 year. So because seasonality we talk about is annual, right? Seasonality is each summer, each spring, each May. But cycles usually is we have longer duration. But this is just general difference. But you can definitely argue that we have a cycle like each hour, still a cycle, right? But usually when we talk about forecasting, cycle is for longer duration. That we can use explanatory approach to capture cycle. We search for another variable which is related to and sometimes leads the variable of interest. For example, the demand for the housing, okay, and it's related to the construction of new homes. Makes sense, right? Does that make sense? Well, this is the first example. Housing starts precede demand for products and services directly related to the construction of new homes. That's a correct statement for you? Housing starts precede demand for products and services directly related to the construction of new home. Make sense? Make sense? Jonathan, why this is true? Why housing starts demand related to the construction of new homes?
Because they're gonna have to know how many people are gonna be living in the area. So they're gonna have to take that data and then figure out a design structure for the homes to adequately, house all those individuals.
Mm-hmm. Yeah, that's definitely correct. Because the builder, when they decide to have more construction of new homes, well, you should know that they must have a better forecast than for the housing demand. If they know, okay, if there's a recession in the future, most likely they won't build a lot of house. When they start to build a lot of house, especially you can see recently, especially in the past 1 or 2 years, now is even in North Carolina, the real estate markets bounce back. Well, if you talk about California, it's already after 2012, the Silicon Valley, the housing price increased like 200% in the past 3 years. But when we talk about North Carolina, especially like Cumberland County, Robeson County, or Moore County, the market is still pretty low, even 1 or 2 years ago. Because I was in the markets back to 2013 and early 2014. Well, the market is still pretty tough. Even last year, my builders still complained to me they built like several houses still on the market. But this year, it's totally changed. This year, the market is really not so hot, but pretty warm. So you can see that the construction is always before the real demand of housing happen. And what else? Let's think about other examples. So for example, if we want to forecast the GDP growth for the next year for the United States, what do you think? What variable you think may helpful for you to make the forecast of GDP growth for the United States next year? Any other factors from school business you must know some other factors which is related to the GDP growth to be helpful for you to make the forecast of GDP growth. In your idea, in your opinion, what factors can be helpful? Jonathan?
Maybe the mean of income generated by citizens. Maybe.
Average, you mean the average income or the
Yes,
mean,
yeah,
medium or
yeah,
mean, whatever.
Like per capita. Like
Per capita. That definitely, yeah, that's the income level we are especially related to the consumption part. Where consumption part, especially in the United States, contributes a lot. I forget, probably more than half of the GDP growth. Well, for some developing country like China, India, like investment parts contributes most of the GDP growth. But for most developing country, consumption contributes most for the GDP growth. So definitely the income level on this side is very important. What else can be very helpful for the GDP growth forecast? Any other factors? No clue about how can we make. But you heard us, we make the GDP growth next year all the time, right? Many organization or even company, they make the forecast. They must have some factors to make the forecast.
This might be a stretch, but the environment where we get our resources from. I mean, maybe.
You mean the natural environment?
Yes. Yeah.
How can you measure the natural environment?
I mean, they have estimates of how many like gallons of oil and natural gas we have,
yeah.
like or how many how many.
I'm thinking about, for example, oil price definitely can be a good indicator for the economical performance.
Yeah.
Definitely, yeah. Let's give you a hint. One factor definitely be very helpful. 2008, you guys still remember, right? You are still pretty young, but you definitely remember 2008, 2009, we have the recession, right? Mm-hmm. Before this recession really happened, because some people argue recession happened already. They come back to history. Some people say the recession happened in 2007. I don't know how can they make this conclusion, but when I was in 2007, I have no feeling about recession at all. My friend, they went to the market to find a job in 2007. Well, they easily get an offer, or multiple offers, very easily. My feeling is probably 2008, later 2008 or early 2009. That's really, we feel the recession, right? But before this recession happen or reflects in the GDP growth or some unemployment rates, is there some other markets or some index reacts before this happen? Before the layoff? Before the shutdown of the manufacturing factory? Is there some other factor already lead before that?
They have the estimates on the stock markets.
Yeah, like Dow Jones. Dow Jones stock market is already performing really bad from Lehman, or even before Lehman bankruptcy, in the middle of 2008. At that time, I can tell you the economy is totally, you can't see anything wrong, especially in the manufacturing sector. Because you know that stock markets always react quicker than the, how to say, the real markets. Why it's usually happen?
People are trading on expectations.
That's right. Usually, people, we are in the stock market, especially like a mutual fund, hedge fund, they know better. They maybe sometimes manipulate, that's the bad side, but usually they know better. But what will happen in the economy or in the financial markets than just an employer working in the Walmart for line, right? They know better. So if they already see the bad side or the potential risk for the market, for the economy, they will, what will they? Okay, they will change their investment strategy, right? Okay, sell their stock and buy some bonds or some, just put the saving accounts, whatever they did. So the stock market first react. I really remember 2008, July or August. So, excuse me. So, yeah, maybe they forgot. I really remember that I was a PhD student at Purdue at that time. So wow, it's a fourth semester. So I didn't have any money in the stock market. But since you are in the school business, you can't ignore the stock market. So I refreshed the Google Finance, everything. Oh, the stock market performed really bad. But as that, I can tell you, many of my friends was in markets. They go to different job fair to search for the interview or offer. 2008, still, many of friends get offer. Didn't show that. That's to 2009, early 2009, even later 2009. The job market totally changed. Well, frozen, layoff, lots of things happen. Lots of things happen. Well, so that is, you can see that's the lag of a lot of market. If you want to see forecast unemployment rates, right, definitely it's like GDP growth, stock market can be a very good factors for you to make a forecast. So you have to know that is very important because for cycle we know it's really hard to make a forecast. You don't know how long the cycle, but there's something can helpful for you to make the forecast. So we should know that. And since you guys from school business, we hope that you have more sense than other people to make this forecast cycle. And we know that if you can react early, you probably will get some opportunity, like stock market for sure. Question?
Yeah. Can you explain the lead variable again? Like when it goes to the construction, you're saying that the construction leads the demand?
The reason is that my personal feeling is that construction, the new construction is determined by the builder or real estate, right? They are professional in this field. When they decide to have, for example, more constructions this year than last year, there are several reasons. Maybe they have better cash flow. Maybe they just be crazy. They have too many labor to want to put the labor in the field. But the most important factor, probably they forecast the demand of housing will increase. That's the reason they increase their construction, right? So, bless you. If this assumption is correct, most times it's correct, you will see the demand, the real demand for the finished house will increase. Right? Definitely, housing markets have two parts. One is the new homes, one is the existing homes. Right? But new construction is only talk about the new home, but they are related. If the new construction, new home market is hot, usually the existing homes are also hot. So that's why we say it's really hard to just, you say, if you want to forecast the existing homes market, it's really hard, right? But with the new construction or new home, it's very good indicator for the markets, for the all houses, including existing and the new homes. That's my understanding, because they know better about that. similar to the stock market we have discussed, because they're professional financial people. They know better about market economy than most people, so they react faster. Right? Same idea. Clear for you, Jack?
Sure.
Any other questions? Okay, so if we want to use these technicals, then we have to introduce these associated forecasting technicals. Well, this is nothing special but the method you have heard of before in the statistics course. The associated technicals are based on development of an equation which summarizes the effects of predictor variables. Predictor variable is a variable that can be used to predict value of variable interest. Like we have discussed, if we want to forecast the unemployment rates of next year, we can use several factors like index, Dow Jones index this year, GDP growth this year. Even sometimes you can just use the unemployment rates this year, and then together to make the forecast of unemployment rates next year. So that's called associated forecast technicals. That's if you have three variables here, that's we can add this to the function. For example, home value. Well, I'm not sure whether probably you guys are pretty young, so you guys probably don't have, most of you have not owned your own homes or houses. But you must know that home value related to so many factors: size, location, number of bedroom, number of bathroom. Right? So that's four. For example, this has four variables: x1 size, x2 location, x3 number of bedroom, x4 is number of bathroom, and then the variable you are interested in is the housing price or value. Right? So that's you can add these two factors into this equation. In your opinion, what is the most important factor to determine the house value?
Square footage.
So you mean the size. Right? When you talk about size, is that the house size or is that the house size?
Land size.
Yeah. So right. So that's two sides that and both matters. Right. What else?
Location.
Location. Yeah. Well, you remember there's a famous word in the real estate markets. Only three important factors for the housing investment is location, location, location. Well, here in Robbins County, probably it's not so true because location is similar. But if we are talking about the big city, not even New York City, if you talk about Charlotte, definitely location is so important. Location. And also, number of bedroom. Give the same size. Well, let's say 3,000 square feet. Well, then the floor plan, number of bedroom, number of bathroom definitely matters. That's very important thing that we should keep that in mind. You can add some other things into these factors when you consider that. For example, like the community. We're going to talk about that. Even the same zip code, right? Very close to each other. The community can make huge difference. You, right? Agree with me, right? If you are in the very good neighborhood, then your house price can be 10, 20, or even more percentage higher than the neighborhood just across the streets. It can be totally different. So, it's the basic idea of this method. Since this model can be very complex, you think about that. It can be not just a linear model, it can be quadratic exponential relationship between the predictor and the variable you want to forecast. But based on our knowledge, we just want to introduce this very simple linear regression model. It's one type of associated forecasting technicals. But it's very simple, it's simple linear model. So, for very familiar with that, similar idea with the linear trend model. So the objective of simple linear regression is to obtain an equation of straight line that minimizes the summation of the square vertical deviation from the line. As you have learned from statistics course, it's called the least square method. That's how can we determine the slope and the intercept. And the model is very simple. It's y equal to a plus bx. You can see it's the same model as the linear trend. But the only difference is that for linear trend, here's not x. What's the symbol of linear trend?
T.
It's t, right? What's that t mean? It's the
So,
Period.
period, right?
Yeah.
Very good. T, with the linear trend, we restrict this predictor variable as the period or the time series. That we restrict that. But if you think about it, linear trend is just a special case of linear regression model. Where you can think about, okay, this variable we want to forecast only depends on the period. Then you replace x by t, the same model. This is the general model. Okay, this x can be any variable. It can be a time period. We didn't say it cannot be a time period, but it can be any other variable like the GDP growth, like the location, like the size of your property, whatever you think is helpful to make your forecast. And then A, B is the slope, and A is the intercept. That's the formula effect is the same.
Yeah.
The only difference is that now we use x instead of t. So if you are familiar with the linear trend, same formula.
Okay.
Nothing fancy, right? Since we already go through the example of linear trend, we don't need to go through another example for the linear regression. You just make sure that linear trend is a special case of linear regression. The x variable become t, time period. So that's the only difference between these two models. But these two models open a much bigger window for us because now we can use any variable we think is useful to make our forecast, not just a time period. Right? Then we need to capture some measurements of our linear regression model performance. One is standard error. If standard error is relatively small, the prediction will be more accurate. If you still remember that statisticals, we have introduced standard error. So the formula to calculate standard error is in this way: is the square root of summation y minus yc. Well, y is your actual value, yc is your forecast value. So basically, it's the difference between just the forecast error, right? It's the difference between your actual and your forecast. And you square them, divide by n minus 2. Right? So the smaller, the better. If it's always y equal to yc, then the error is equal to 0, which means you have a perfect forecast. Another measurement is called correlation coefficient.
Just a quick question. What did you say was when is the perfect zero?
If your forecast yc is equal to your actual value y,
Okay.
then this error becomes 0.
Right.
Summation sc equal to 0, which
Oh,
means
so
you
it's
have a
perfect.
perfect.
Okay,
Yeah. But,
gotcha.
So which means the smaller the better. Right?
Mhm.
But most likely we won't have this perfect model.
Thank you.
So another performance measurement is called correlation coefficient. So which will measure the direction and the strength of a relationship. Well, it's given in that pretty complex formula. N times summation xy minus summation x first times summation y. This is the numerator part. And denominator, which is n times summation x squared minus summation x first, then square. And take the square roots times square roots n times summation y squared minus summation y first, then square. So it just be very careful when you calculate that. Okay, I know some guys are laughing. Yeah, but just be careful. It's really hard for me to explain that it's just a formula. Okay, so just be very careful. Okay, but any question about this formula? Some parts you are confusing or wants me to explain. It's clear? Not clear, right? Do some practice. We'll have an example in the homework. Should be fine because in your exam maybe it will ask you to calculate. Yeah, right. Correct. But you have calculated that in business statistics too, I believe.
Yes.
Right?
Just
Definitely.
Running it.
It's just remembering the formula.
Yeah.
Remember from me, yeah. That you
It's
know.
open note.
Open the open book.
No problem. We have open book.
There you go.
Our example will be open book. Jack?
So we have to show how we get it for this too, right? On the exam, or can we just use the calculator and get it?
You just use the calculator. No, I mean not the program calculator. You have to plug them in.
Okay.
You remember that? If you use a program calculator, I can't tell because the problem is that one thing is that okay, first I don't know whether you really understand this one. Second, if you get the answer wrong, I can't give you any partial credits. I can't. I simply can't give you any partial
So
credits.
that's cool. So
Right?
even
If you show this formula, you plug in the number and the final result is not correct. Usually, I'm very generous. If you just get the final result
Stop.
incorrect,
like that.
I will give you at least 70% of the
Oh,
point.
Oh, that's
But,
cool.
but if you just give me,
Awesome.
when you say, okay, correlation R equal to that, I don't know what number you plug in, and you get the wrong results. So what I can give you? That's really hard to give. So, but if you write this formula, you plug in the number, just plug in the number, and then you find the final results not correct. I can understand that, right?
That's perfect.
Alright.
My job is not to fail anybody here. My job is try to threaten to fail you guys and push you guys to learn as much as you can. Okay, I know it's a little bit tricky, but this is the balance of my job. First, I have to threaten you guys. I can't fail anybody. I definitely can, and I did fail several people, students before, and continue to fail students. That's my job, right? If you have to fail, you have to fail. But this is not my ultimate goal of my job. My job is that under threatened by chance, you can learn as much as possible. Okay. Open book, open notes, don't worry about that. So R squared is a percentage of variable in the value that's explained by the independent variables. It range from 0 to 1. One thing, I'm not sure whether you statistics faculty, Victor or Richard, they have remind you guys for this R squared. This R squared, the tricky part, the large of the R squared only can tell you that's a positive relation. For example, if your R squared is like 80%, it demonstrates a very positive relationship between y and x. But it doesn't mean it has a very positive linear relationship between y and x. You understand the difference? They can be quadratic or some exponential, they're still positive, right? But linear relationship, you have to determine by plots. We have decided plots. Then you can tell. A quadratic or exponential, think about that, also have a very strong positive relation, but it's not linear. It's very important. R squared can only defend you, okay, they have positive or negative relation. R squared is positive relationship. But it can't define why you want to use a linear regression model. How to define that? Why you want to use linear regression model? Plots. Then you can define yourself well, right? Now some assumptions is pretty boring part. This is a review about statisticals. You have to have these assumptions before you can jump to use the linear regression model. Variation around the line are random. Deviation around the average value should be normal distributed. And the prediction are made only within the range of observed values. We have some issue we need to consider before we use the linear regression model. Plots. I really appreciate my professor. She's Canadian, and she told me 10 years ago. Okay, I still remember now. I believe I will remember the rest of my life. Okay, when you jump to any model, especially you are so confident about linear regression model, don't jump in the first step. Plots before you are so confident. Well, hopefully it will make you more confident after you plot the points. Right? But if it's not a linear regression or linear relationship, we have to accept that. Well, maybe we don't know how to use that. The any model we can explore later, but first justify. Okay. If the data is time dependent, well, linear regression model become time series model. We can use a linear trend. It's just a special case of linear regression. Okay. You can also use the time as one independent variable in the multiple regression analysis. That means only one variable is t, but some other variable include like the housing size, like the number of bedrooms. That can be included in this model. Okay. If you have your regression model and you calculate the correlation, it's very small, like say 20%, 30%. That probably means you have missed some important factors in your models. Probably want to explore, is there some other factor helpful? No. But this argument here is by definition of small. So now I have questions. Probably you have some discussion back to statisticals. For the correlation, well, we know that it's between 0 and 1. We know the 1 means it's perfect, positive correlated. 0 means there's no relationship at all. In your opinion, or what you have learned before, what's the range of small correlation? or large correlation or mean. You have linear regression model. We calculate R square. Usually you define, okay, they have very strong relationship. If you say they have very strong relationship, what is the threshold of this R square? Any idea?
80,
Memory?
80%.
80% about
Or strong.
or strong? Mm-hmm. Same?
Does it have to do with the bell curve, or is that am I kind of far off from that?
What do you mean by bell curve?
Yeah.
You mean?
Like the standard bell curve, you know, goes 5%. Then
Oh, you mean the normal distribution?
yeah, that's right.
Okay.
Is that kind of
Not really, because R square is different with the yeah, statistically you can connect, but it's not really not
Okay.
direct connect to that. 80%? Everybody agree? Any other number? We say they have strong relationship. You must be 80%. If that's Richard or Victor teach you guys, I will come back to ask them.
95?
95?
Yeah.
This must be a magic number you from other chapters of statistical like hypothesis tests, Franco. Because definitely not 95% for this answer. But for hypothesis tests, you will use like 95%, 90% loss. You test whether they have like the a very strong relationship or like whether the population mean equal to sample mean, something like 95%. 80%, well, it can be true in many textbook or academia criteria, 80%. Different teacher or different type have different. Most type wouldn't say anything about that because no matter it's 80% or 70%, for industry is too high. What I tell you, like 20 years ago, even for industry they follow academic rule. And I'm saying 80%, 70% at least. Otherwise, how can you define they have a relationship, strong relationship? And in the past 20 years, many companies have very complex model. Make the forecast very hard thing to make forecast. Then 6%, right? 55%. Many companies think it's enough. It's okay to use this model. Nowadays, it will change dramatically because of big data. You think about what does big data mean? Right? What does big data mean? Have you heard about big data? Everybody heard that, right? Big data, everybody heard that. But big data is nothing fancy in my opinion. It's just a statistical tool expand to big data. You still can use regression model to run that, but you just need to collect more data or more factors. But think about it, you have more data, more factors, that's more noise. Then when you have, for example, a regression model, you throw in 100 factors, to make the forecast or something, even you don't know what's going on. Sometimes you get 40% on square. Nowadays, it can be acceptable depending on your situation. So that's what I want to emphasize that when you go to industry work, R square it depends on your individual company. Or 70% most time is good enough. But 50%, 65%, well, you should be cautious whether it's a good model. But sometimes now, especially nowadays with big data, there's a lot of noise. It's still acceptable in some occasions. That's what I want to say. Because in academia, they can be different with industry. What's within here? Theoretically, they're the same, but the threshold, the criteria, they can be different. Question or comments? Clear? So then why you are teaching us here, right? There are different criteria, but here they are different. But the calculation, the formula is the same, but just the threshold can be different. I hope in the future with UNCP we can have a course on big data industry because nowadays, have you guys heard about big data? Raise your hand if you have ever heard of big data. Nobody have heard of big data? You? Yeah, right? Just you? Nobody else? Big data? Really? Have you heard of big data before? No big data. So you should hear about big data at least because nowadays when you go to industry, everybody's talking about big data in the past 2 or 3 years. Everybody's talking about big data. Well, that's exactly many companies are doing. Facebook, Google, Amazon, Microsoft, definitely this internet company. You think about internet, there's a lot of data available. Right? Click data, web browser data, lots of data. right? You have how many 200 friends in Facebook, 150 friends in Twitter, another 200 friends in Snapchat. This data seems useless, but they have data. Well, they can Google especially they can easily track whatever you browse if you use Chrome. Unfortunately, they know that, right? And they have a lot of data about just one customer. If they're talking about like millions of different customers, that's a really huge data set. They want to dig hard to find any value of this data. There's a lot of value. For example, they need to know the market targets, whether you really want the new Google Glass. They have no idea whether customer really like Google Glass or not, right? But they dig big data, your browser history, your click history, your friends, your in the network, LinkedIn, they can figure out a little bit. So there are lots of things on advertisements. You can think about you go to some websites, you and your friend will see the same website show different advertisements. Why they show different advertisement commercial in the website? Because they analyze your profile. For example, girl, Christine, you go to some websites, Facebook will recommend the shoes. Well, Jonathan, they will recommend shoes, maybe just soccer shoes. It's totally different, right? So why they know that? They already analyze your profile by doing the big data. So, which is very hot nowadays. Why? That's the reason. If you have never heard that, I definitely suggest you Google or wiki that what is big data mean. Because when you do the interview later, if they mention that, at least you know this idea. Even we haven't have any course in school business to deal with that. But I believe in computer science, they must have some course to deal with or talk about big data. Okay. Next, how to choose a forecast technical? There's so many factors we have to consider, like cost. Well, usually the higher the cost, the higher the accuracy, right? And if we pay a lot of money, we probably can get some software. And also we have to consider whether our availability of historical data. We have to consider the time to get and analyze the data. Horizon. Right? Let's talk that. Those one by one, some things talk about that. The first one, second one, we all know that about these two. Talk about the third one. Availability of historical data. Well, this can definitely affect your performance. Even you have, like my previous company, you come to Terra Technology, say, okay, I want to use a software, I have $1 million, I pay to you. Give me the best forecast you can. And then Charles was assigned to this project. I find, okay, give me 2 years historical data. That's the typical data we ask for our clients. My client told me I only have 2 months. That's done. I can't do a project because if you only have 2 months data, please come back after 22 months later. That's my suggestion because well, I can't guarantee. You pay me a lot of money, then finally you will get disappointed. It's not good for our brand. You need to have historical data and good quality with good quality data. Otherwise, it's garbage in, garbage out, right? Good historical data. Then we can dig this data or even big data and you get the results. Unfortunately, even for 500 Fortune 500 company, many company or many sites, they don't have good historical data. I'll give you an example, Unilever. Since I did a Unilever global project for different regions. North America is, in fact, they talk about North American project is in fact just United States and Canada. And European projects, they're talking about like 13 countries European, most countries, from Britain, France, German, Belgium, most especially Western European countries. And I did it for India Unilever project, so just India in Asia. And did Cordillera, we can say Latin American Unilever projects. I believe they are doing the Argentina, Brazil, Mexico, some other countries. So this project cover most continents of the world. So you can imagine, for these 4 projects, North American, Latin American, Indian, and Europe, in your opinion, or you give me a guess, which region have the best historical data? North American, Europe, Latin American, and India. Which region, which branch have the best historical data?
India.
India. The answer is not correct. With those other gases, those correct.
Europe.
Europe. Why you guys are not proud of your country? United States and Canada. And not just United States. United States and Canada. Why you think? What's the problem here, right? I'm from China, but I have to say United States has much better data than China as for you neighbor. United States has the best data. Well, it's understandable, right? You're not proud of your country anymore. United States has the best IT infrastructure. Has best. Europe definitely is also good, but Europe have the problem is that because there's so many countries, the conversion can be a problem, right? Units of measurements, you can see the pounds and the Europe dollar, Europeans, and then if you have, but they have a lot of conversion issue. That's you must know that because different countries have different measurements, right? So Europe, we can't say that not so accurate. This is the second best. But U.S. Canada has the best data. Even U.S. is better than Canada. We have to do the internal comparison. U.S. data quality is better than Canada's. So U.S. is best. The second one, okay, as most of you guys vote, is European data. Your neighbors had quality in Europe, so they should be number one. But in fact, U.S. has the best data quality. And Latin America and India, yeah, they are not so good. It's especially India. Not so good. Well, you can see this Fortune 500 company, they already have the IT infrastructure, uniform IT solution for all the sites. Question? Jonathan? No. They have the IT solution for all the sites, but because of management issue, knowledge base, some branch or some site, they don't have a good historical data. That can definitely create a headache when you do the project. I can tell you, if you have good data in the United States, don't give me 1 year. 9 months is enough to finish the results, finish the project. India, we spent 2 years with the bad delivery. They are still not satisfied. We try our best. 2 years. Because the garbage in, garbage out. Definitely, we can't talk with clients with garbage in, so we have garbage out, right? But we know that the root reason why we can't have a good forecast for airport. Well, I have no discrimination. I just talk about this. I for some other company, maybe Latin American or India have better data than US. Just my experience. Anybody feels offended or discrimination, just based on my experience. But generally speaking, it's true that developed country or big company have much better historical data than company in developing country or small company. Reason? Because you have a lot of investment. You have to collect data. You have the machine, even the scan machine. If you are just operating a convenience store, probably you don't have very clear historical sales data, right? But if you are Walmart, definitely you should have. So that's the thing to keep in mind, especially when you work for small, middle-sized companies. The reason that when you just have your company, beginner company, or in a middle-sized company, you probably don't have enough money or efforts on collecting good historical data. You think, okay, it's not our urgency, and we want to expand, we want more clients. But you will to the point, once your company become big, you will go to the point you can't handle by your hand by forecast. You want to use some software or even your Excel templates, then historical data becomes so important. And you should prepare in advance, instead it's 2 minutes. And software is very useful, but usually it's very expensive too. Horizon, we have discussed in the beginning of this chapter, right? That's a way automatically gets a better forecast by using closer horizon data. Right? If you make the forecast for next week, it's definitely better than make your forecast for 2 weeks later. If you can shorten your forecast horizon, you use the shorter horizon data, you automatically get a better forecast. How to do that? Collaboration, cooperation, right? You ask your truck driver, okay, instead of tell you the plan 3 weeks early, can we just tell you the plan 2 weeks early? Well, they probably don't like that, but you tell them if that's, you can save 5% of the cost by better planning, right? You tell your supplier, instead of I have to make the purchase like 1 month early, can we make the purchase just 2 weeks early? The reason is obvious. If we just make the purchase 2 weeks early, we have much better forecast of our demand. But they heavily maybe you have to negotiate, maybe pay extra fees, you have to balance whether it's worth to do that. But the idea is that the shorter of the horizon, the better, more accuracy of your forecast. That's you want to keep that in mind. So, two different approaches for the forecasting. The first one is the reactive approach. That's all the methods we have discussed so far belong to this approach. Well, we just react to meet our demand. We make our forecast, collect historical data, collect whatever, and to make our forecast. Okay, we make a forecast. Unfortunately, let's say we have a recession, and we prepare that. We shut down, we lay off, prepare for the recession. That is the reactive approach. The proactive approach, we want to see activity influence our demand. For example, if we have seen our demand will drop next month, we can do advertisements, right? Commercial, okay, to improve our demand. Then help with pricing. iPhone 6 Plus, iPhone 6s will come to the markets next week. You guys know that? Okay. So they can definitely use pricing to affect their demand, especially for Apple. They can set a high price, the demand won't be so high initially. On the other hand, you can have some promotional discounts to boom your demand. Our modification we have discussed about customization definitely is very helpful to shape your demand. Why do we want to improve our demand? What's the motivation we want to influence our demand? If we have a perfect forecast, let's give you an extreme case. I have a perfect forecast. I tell you, okay, your next week demand is 100, and then 200 for the week after next week, and then back to 100, and then back to 200. But it's perfect. It will have exact the same demand as my forecast. 100, 200, 100, 200. Were you happy about this result? Perfect forecast. That's the problem still. What's the problem? Yeah, that can be, but most products like that very stable as 100, 200. But what's the problem? 100, 200, 100, 200, 100. Think out of the forecast. I can tell you forecast is perfect. Demand is not falling, demand is just up and down, up and down. No problem? Think also forecast for some other departments in operation management. Is there any problem?
You got a large variation in what you need your inventory to be.
Inventory, production, transportation, scheduling, all are affected. Even you get perfect forecast, for the purpose for the forecast is helpful for other departments, right? Definitely, 100% accurate forecast is helpful. But you give me this data. If I am the production manager, I will be very frustrated about this forecast. What else will happen in the future? It's really hard. I can't lay off people week 1 and help them again week 2. It's really hard to make production. Well, I can make a smooth production. Then inventory manager will complain. You make 150 every week. So the first week I have extra inventory, the second one I have a shortage, something like that. Transportation complain a lot. Says my truck is overloaded the first week, it's half empty next week, again and again. That's the reason even your forecast is perfect, still you want to affect or influence the demand like Apple did. Okay, they don't like if their demand is so high or so low. They want most companies want to smooth their demand pattern. Makes sense, right? Want to smooth their demand. Even you have perfect forecast, you should still keep that in mind. Okay, you don't like the pattern, then you can use these tools to shape your demand. Okay, to shape your demand, most time we want to shape it as smooth as possible, which is very helpful for our other departments. Okay, the last page, the strategy, you can read it by yourself. Okay, that's the end of today's class.